Alright, welcome back to my YouTube channel once again. This is the fourth series of our gas law. Started with Boyle's law, and we move to Charles law, then we move to general gas equation. Now we are at what? Ideal gas equation. Ideal gas. Equation. Now, ideal equation is the combination of Boyle's, Charles, and Avogadro's law. Okay. Now let's see how this formula we can derive it. Boyle's law is volume inversely proportional to pressure provided temperature is constant. While Charles law is volume directly proportional to what? To temperature provided pressure is constant. While Avogadro is directly proportional to number of mole. So let's put that together as one equation. Something is common to three of them. And what's that? Volume. So volume inversely, directly. Can you see that? So we can have, introduce popularized constant K, we can have NT over P. Can you see that? P is inversely proportional. So if I want to make my K, so the formula, I'm going to have K equals to what? So I can even cross multiply first. Let's cross multiply. Let's do our cross multiplication first. Then we have PV equals to K N and T. Alright. K here equals to R, which is what? Constant. Okay, we call R the gas constant. So let's make our analytical formula. We have PV equals to R and T. So let's make the R solid formula. We have PV equals to N and T. Let's use small letter N as a number of mole. Now, what are the value of all this? For now, our R does not have value. We are going to derive that. And our P here is 1 ATM. Remember, I told us in previous video that STP of ATM. Our V here is 22.4. Remember, I said at STP. Then N, that's 1 mole. Okay? And the T is 2273 Kelvin. Unit is very, very important. So let's derive our R. Our R now, using this formula, R equals to our P, which is 1 ATM, multiplied by V, which is what? 22.4 dmq. Alright? Divided by our N, which is 1 mole. Okay, multiplied by our T, which is 273 Kelvin. So our R becomes what? When you divide all these things, divide them, one cancel one, divide, you have 0.082. The unit becomes ATM, becomes dmq, becomes per mole, and what? Per Kelvin. This is what we have as our R, and this is how we derive the value of R. Can you show it quickly? This is how we derive the value of our R. R is equal to what? 0.082 ATM dmq per mole and per Kelvin. Did you get that? It's very cheap. Okay, let's just take a look at how we can use this formula to tackle some problems in chemistry. Quickly, let's look at example 1. Okay, follow me quickly. Let's look at example. A certain amount of a gas occupies 5.0 dmq at 2 atm and 10 degrees C. Calculate the number of moles present. Of course, at STP, what we have, our gas constant is 0.082 per mole per Kelvin, ATM dmq. Let's look look at how to tackle that kind of question quickly. Look at the parameters here. I like giving out parameters to know exactly what I'm doing when I'm teaching students. Now B is this in this order. Okay, let's really use our formula. Our formula is PV equals to nRT. That's our ID gas formula. Okay, what's our N? P is equal to 2 atm and our V is 5.0 dmq. Okay, all right. Equals to what? N multiplied by our R is 0.082 atm dmq per mole and per Kelvin, multiplied by our T, which is 270. We are going to change this one to Kelvin. That's plus 273, which gives us 283 Kelvin. So we have a 283 Kelvin. All right, 283 Kelvin. 283 Kelvin. So let's really do that mathematics. All right, make exercise from that. N equals to 2 atm multiplied by 5.0 dmq over 0.082 atm dmq per mole per Kelvin. Okay, multiplied by 283 Kelvin. All right, let's quickly do our final answer there. Multiply this by this, give us 10 divided by 0.082 there. You are going to have our final answer to be 0.431 moles. Let's check our units whether we are correct with our units. Now, this ATM can cancel out this ATM. This DMQ can cancel out this DMQ. While this Kelvin can cancel out this Kelvin. Because of this, we're going to have this thing making what have the moles, not per mole, moles. Because this is 1/1 already. So our final answer N is going to be what? In moles. Did you get that? Did you get that? Okay. Let's really move on to example number 2. Example number 2. Okay. Look at the screen. 2.0 moles of an ideal gas are at a temperature of minus 13 degrees C and a pressure of 2 atm. All right. What volume in dmq will the gas occupy at that temperature? So our gas constant is 0.082 atm dmq per mole and per Kelvin. Quickly, let's look at that. Let's look at what we can have. So we have our same formula PV. You can look at the parameters quickly on the board. Look at the parameters on the board. Look at the parameters. PV is equal to nRT. Okay, I'm looking for V. Let's limit from formula. I have V is equal to nRT over P. My N is was 2 moles multiplied by my R is 0.082 atm dmq per mole per Kelvin multiplied by my T. Remember to convert this. I have 260K. That's 260K all over P. Your P is 2 atm. Okay. Now, when you look at that, pick your calculator and let's quickly calculate that value together. If you calculate that value, you're going to be having 21.32 dmq. How did you get that? Okay, pick your calculator and calculate that. Let me quickly cancel out the units. ATM cancel ATM. Mole is per mole, cancel that mole. Okay, this Kelvin and cancel out this Kelvin. So we only have the MQ. That's our unit. And that's what the question says. That we calculate the value of V in what? In the MQ. Hope you are following. Let's quickly move to the third example. Example 3. Calculate the pressure at 27 degrees C of 60 grams of oxygen gas occupying 2.5. Now, of course, our gas constant is going to be R is going to be 0.082 per mole per dmq, all of that. Okay, let's look at the parameters on the board. Please show the parameter on the board. Our T is this plus 273. That's giving us 300 K. Our mass is given, volume is given. Now P is not given. Okay, and what else is not given? N is not given. So we have like two parameters. We're supposed to use this formula PV equals to nRT. Alright, we have our T, we have our R. Our R is equal to 0.082 atm dmq per mole per Kelvin. This was supposed to have. Now we don't actually have our N and we are looking for P. So but we have been given parameters that we can use it back later. Remember, as a chemistry student, you're supposed to know this one. N equals to M over M N. Our N, that's what we are looking for. Our M is 16. Our MM is oxygen gas. And oxygen is 16 times 2. Okay, we give us 32. So divide this, we are going to have 0.5 moles. That's our N. Okay, let's substitute our volume. P multiplied by V, which is 2.5, 0 dmq, equals to 0.5 mole, 0.5 mole, multiplied by 0.082 atm dmq per mole per Kelvin. Okay, multiplied by our T. Our T is 300. Okay, can you see? Can you see 300? Alright. So let's make P to a formula. P becomes this. When P becomes what we have, now we are going to have P is equals to 0.5 mole multiplied by 0.082 atm dmq per mole. Alright, making my P formula, I have P equal to 0.5 mole multiplied by 0.082 atm dmq per mole per Kelvin multiplied by 300 K. Then divide both sides by what? 2.05 dmq. So let's do our units. This one cancels out. This cancels out. So our final answer must carry what? ATM. This Kelvin also carry. Now let me give you one small time to calculate that. So in calculating that, we're going to have something like 4.92 ATM. Did you get the same thing? 4.92 ATM. That's P. Remember. Now let's look at example 4. Example 4. The question says the pressure exerted by a sample of a gas confined in 5.86 dmq container at 20 degrees C is 4.1 atm. What is the number of moles of gas in the sample? Gas constant R is 0.082 dmq atm per mole per Kelvin. So let's really dive in together and see how this question will look like. Now let's look at the parameter. Your V, your T, your P, your N is unknown, and these are our gas constants. We are going to add 273. I'll give you 293. Okay, we're using PV equals to nRT. Okay, we can make our N squared formula. N is equal to PV over RT. Okay, let's place substitute. Our P is what? 4.1 atm, and our V is 5.86 dmq over our R is 0.082 atm dmq per mole per Kelvin multiplied by our T, which is 293 Kelvin. Alright, the number of mole will be, when you do the calculation, press your calculator, you get 1. That's your number of mole will be 1. But what's going to be our units? ATM, go with the ATM. DMQ, go with DMQ. Of course, per Kelvin, go with Kelvin. So we have mole. Okay. Because you have 1 here, we have moles. Okay. Thank you for watching today's video. I'm still here, your chemistry master. See you in the next video.